Okay, so hello and welcome back to another Unity shader tutorial. In this one we're going to be writing a kind of water plane shader, and here's what we're going to be making, but you can also take this away yourself and add a scrolling texture on it or tweak values and colors and whatever you want. Just basically make it your own. At the moment it's just kind of like an actual like wave kind of machine. It's basically making a cos wave, a cos curve. And pushing it along almost, if you get what I mean. So like it's moving along with the time function. We'll see. I'll show you. A lot of people liked and watched this video here, which was the shader graph noise, like the vertex displacement. But to be honest, like that's just like a worse version of this. The reason why is because, well, when I'd got into the position node in shader graph, I was just kind of messing around and, you know, like, ooh, this looks odd, not really cool, looks interesting. But now that we can like now that I've got into writing proper shaders, we can make better effects that we want. So let's just get rid of this. So here we are. Let's delete the material. Actually, before I do that, I'll quickly show you. We can also tweak the speed at which it moves. And we can also tweak the amplitude of the waves. Obviously, limit that to what you want, but you know, you could have some pretty steep waves. Also, this effect will look smoother the more vertices your plane has. So if you want a vertex that has more planes to be smoother, then go into Blender, get a plane, subdivide it, whatever. But if you're going for a low poly look, you could keep it like this. You can also make it, I guess you could change it so that it offsets it in multiple directions rather than just on this one direction. But I'm going to keep this wave effect. You can take these videos away and do what you want. One of the main things about learning is obviously doing it yourself. So this is kind of showing you how to set up the basics. Let's get into it. So we're going to delete the shader, and we're going to go create new shader, unlit shader. Well, it doesn't really matter because we're going to be clearing it, and we'll just call it tutorial 05 shader. Yeah. Onto the material here. Now it's just got the default thing, it's taken in a texture, who cares. Let's open this up, and it has opened it on my other monitor, so just give me a second. It doesn't seem to want to work. What I can do is I will simply delete this and just create the shader, and I'll just call it wave shader. Just put that onto the material and open that instead. Here we are. Let's just bring this over here. So wave shader, let's first of all just get rid of the default Unity stuff. So we want shader custom slash waves, and then we will open it up, and we want properties. What properties do we want for this? We want you want your plane to have a color, so a color like that. Well, doesn't really matter, but color. And this one matters. It has to be spelled right here, color, because this is the type. And it's going to be, by default, we'll just leave it white. Don't know what those sounds are going on outside. We want a strength of the waves, so like how high they go and how low they go and so on. And this is going to be a range, and then we can put in our own range. Now I had it on 0 to 4, and that was pretty extreme. Honestly, you can put what you want here, because obviously you're going to put it to the right value. I'm going to limit it 0 to 2, because that was really high, and we'll leave it at 1.0 so it knows it's a float. So this is the speed at which it moves. and this is going to be between. See, you could go for negative values here and it would just do the effect backwards, but it's basically not going to be noticeable. I mean, we could always go for it, so we'll go like minus 200, 200, and we'll leave the default at 100 or something. Alright, that's the properties done. Next, we want the subshader. In here, we want the... We can make it a transparent, because it's a water plane, you might want it to be, you know, transparent. So what you want to do in tags is you want to go render type equals transparent. You want it to be exactly like this. Also, I've kind of given up trying to do the formatting with the brackets. As long as they're in the right place, it'll work. It doesn't matter how long like the line it is. This doesn't like shaders, I guess. So after we've done this, we want our pass. Now, what are we gonna do for this? Well, because it's gonna be transparent, or it can be transparent, we're gonna do cull off, which basically means we're not gonna ignore and cut out certain pixels that are behind other ones, because we want to be able to see them, possibly, if we can, because it's transparent, we might be able to see some of it behind itself. And then this is where we're gonna start our CG program. And I'm going to do end CG now, just to make sure I don't misspell it like last time. Alright, we need to do the pragmas, the functions. So, pragma, vertex, func. Let's just... I know I said I don't care, but I will indent these. Fragma. Actually, so people don't complain, I'm going to zoom in. Okay. Fragment. Fragfunc. And then, now that we've got these defined, we need to bring down our properties. So let me just go up here. So we need a float for color, a float strength, and a float speed. So now we can access those down here. Now what do we want to do? We need to have our functions. So we've got our vertex and our fragment. Now before we actually make these, we're going to make some structs. So if you remember, struct is kind of like telling the thing what kind of properties we want it to have. So if we have a because we're going to be passing in vertices and passing out, so this is one way you can do it. We'll say we have a float for vertex. That can be called what you want, and then here it has to be position, which is the position of the vertice, and then we'll have a vertex output float for pos. We've been through this before, we've done this before. I don't need to explain it again, but now we're going to write the main body of our the main body of the code. So first of all, we'll just write an empty vertex function. So let me just so it's of type vertex output, and we've called it vertex func. Make sure you name stuff right. And we're taking in vertex input as our in. Alright, now let's just say we have a vertex output O, and we're going to return O. Not 0, sorry, O. And then let's go down here and we'll say we have a float for fragment func. Vertex output, and we take that in, and it derives from color. Alright, and then we're just gonna return color, because in this fragment function we don't need to do anything with the color of the pixels that are gonna be the color, you know. Now if we run this, maybe we get some, okay. What's going on here? It's giving us some problems. Vertex. Okay, I spelled something wrong clearly. Unrecognized identifier vertex. You know. Because I put vertex in out when it should be in put. Line 14. Line 14. It's saying that there's a problem because I haven't opened it up. So if that's the open, and then it's going to be closed after the there's too many brackets going on here. Almost there. 35. Vertex out. What am I doing? Vertex output. 42. Was that not necessary? No, I think it was just in the wrong place. So we've got that there. It's meant to be there. Okay, nice. Only one more from on line 34. 34. Vertex output. Let's see what I did wrong here. Vertex output. Vertex func. Vertex input in. What's the problem? Let's just check back with Unity. Output variable contains system inventory value. Okay, it's because we haven't done anything with it, and then did not find shaded kernel fragment. Wait, why did I put frag? Boom. Fingers crossed. Okay, so the only problem is that, which we're going to do right now. On line 34, it's saying. Because we basically haven't done it. So, what do we need to do? We need to write stuff in here. So, float 4. We need the world position of the object, not its own position. We need the world position. So to get the world position, we get, now Unity's going to tell me off for doing this, I think, because it's an older way, but Unity object to world, capitalizing it, right? And we're taking out the input dot vertex, which is in dot vertex. So basically we're getting, it's pretty obvious, Unity object to world, and we're taking in the vertex that we're currently on to get its world position. Simples. And now we need some way to know basically we need to know the displacement. This is going to be the value of how high or low the vertex we're on is, which will obviously end up forming a wave shape. So we want it to go on a cos, which will be, between 1 and 0, because if we have sine and it goes between 1 and -1, then, I mean, obviously it doesn't matter. You can still do that if you want to. You'll obviously get a slightly different effect. Sorry, no, it's cos that goes between 1 and -1. So this is what we want. So basically, if we have our graph, and let's put in our values now. So we're gonna say the cos of, and then we can take in our y. If we want to access the y, we'll do world position dot y. So this is obviously the y position of the vertice or the vertex, and well, we could just say the cos of that, but we want to be able to basically change it. So with our input, so we're going to now get the cos of, because we want to keep it all between the values. We're going to get the x of where we are in the world. So that basically, as we go down the wave, it still has the same effect on the, depending on our x. And then we're going to also take this, add on our, we want to add our strength. No, we don't. Our speed multiplied by the time. Now, time is a variable that is just in the shaders, which basically, unlike the sine time and cos time, this one just keeps increasing forever, which means this effect doesn't go forwards and backwards, it keeps going forwards and forwards and forwards. Okay, so now we've worked out our displacement. What do we want to do? We want to take our the y position of our vertice, and we want to set it equal to where it currently is, so world pos.y plus, and then we want to increase it by the displacement that we just calculated, so displacement, and we want to multiply it by our strength. And I hope that makes sense to you. So obviously we can change this, like how displaced it is, with our strength variable parameter property, whatever you want to call it. It's basically the same thing in this. And then now we just need to pass it out. So we want to say the position of this vertice is, and then I don't know if I've covered this before, just go along with it. Unity matrix VP. VP, basically there's loads of different vertex, matrix functions and helper things. VP is vertex position, if I'm not mistaken, pretty sure. And then we can just pass in the world position of the vertice to get the position. And then we've got O returned. And now, all we need is to go and fix that typo on line 39. And we should be all done. And here we go. Alright, let's take our material, probably lower the strength, press play, and have our fingers crossed. And there it is, and obviously I can increase it to 200 if I wanted to, and then minus 200. It just does the effect backwards. It is noticeable, you can obviously do it whatever you want. But yeah, here's the effect. So, there's the tutorial. There's not much more else to say. Obviously, if you want to keep seeing more shader tutorials, then feel free to ask specifically what you want to see them on. It would mean a lot if you liked and subscribed. It would help support the channel a lot. I am so close to 1,000, and I'm looking forward to doing a 1,000 sub special and some other things at that point. But all the support I've been getting is amazing anyway. All the comments, everything. It is really nice. If you want to join our Discord server to have discussions and ask for help and whatever else, then feel free, go ahead. It's a good community. The link's in the description. But apart from that, thanks for watching and goodbye.